My name is Tim Dowling. I'm a planetary scientist here in the Physics and Astronomy department. I work in atmospheric dynamics of all the different planets. And this summer, quite by accident, we've been working on Mars. Usually I try to avoid the popular planet, and it's a little quieter that way. But if you've been keeping track of NASA's history over the last couple of years, NASA has actually lapped the solar system. So they came back around to Mars, and I was there. So I'll actually show you a little tiny bit of the research that we're doing here at the University of Louisville on that. But mostly I want to bring you up to date on Mars today, on what's going on the planet today. It's been in the news. And also Hollywood has had a nice little ride with Matt Damon trying to survive on the planet. How many people saw the movie The Martian? How many people read the book? How many people read the book first? If you haven't done either, I would definitely recommend read the book first. It has about 500% more detail in it. It's actually a series of word problems. Put the protagonist into a situation and see what it would take to get out of it. And you just cobble those together over several years. Interestingly, the book The Martian came out in 2011. This is 4 years ago. This is the same year that the big discovery I'm going to show you today was first discovered, which is liquid water running on Mars right now. And NASA made the announcement of that just a month ago. So why the 4-year delay? Well, that's one of the things I'll cover. But basically, NASA is trying to be very careful with this, and they needed spectroscopic evidence of water, and they got it this year. So with that, I'll go ahead and launch into our talk. This is Mars today, and how many of you recognize this rover? We've got quite a few rovers, a lot of hardware on Mars right now. This is Curiosity, and this is Curiosity taking a selfie. And you might ask yourself, how the heck did it do that? Well, it took a mosaic, so it took a shot, like if I were to take a selfie right now, if I took it here, and then here, and then here, and put them together at very high resolution, even better than my phone, and then just sort of edited out where the camera was. The only thing that gives it away, if you actually see a larger version of this figure, the shadow of the mast is actually on the ground on one of the shots. But it makes her, you can't see the seams or anything, absolutely gorgeous selfies. This is Curiosity, which is a very, very heavy, large object. You can see it's just covered with dust. It's filthy. It's been hard at work. And we'll see some of the data that came off of it. That mast there has a nice camera on it. We'll get some data from that. Okay, let me talk mostly about Mars today because that's what's exciting. But let me give you some background. Mars yesterday. Who was born before 1940? I don't see any people left. Anybody? Don't look like it. That was when my parents were born, 39 or 40. In 1940, this is what Mars looked like. This is a still from a cartoon, an MGM cartoon called The Milky Way. It's a cute little cartoon. It's got three little kittens that are looking for milk by basically going through all the different planets and looking for the Milky Way, looking for milk. And so they illustrate all the planets, and they very briefly go by Mars, and Mars is this incredibly violent thing with all these cannons going, just as you see here. And what it's doing is it's making shooting stars. So in 1940, this was Mars. Mars was red, it was blurry, it was the god of war, had a couple of canals on it. That was it. That was Mars. So that's our starting point in terms of human culture. This is the 1940 MGM cartoon, The Milky Way. This is what Mars is yesterday in terms of scientific analysis. What you see here is a still showing the incredible violence of the solar wind blasting with its charged particles across Mars and just stripping the atmosphere off and any liquid that would be on it. And the reason this doesn't happen to us, as you'll see in a second, is we have a magnetic field. So one of the themes you'll see today is that the differences between Earth and Mars are all in favor of life on Earth. Everything about our planet that you can think of, even to the incredible detail like plate tectonics, a big moon, all of those details are actually beneficial and help life incredibly. There's really nothing about the Earth-Moon system that's harmful to life. And almost any one of those taken away, and it makes it very difficult to have life on a planet. And Mars is actually missing a couple of those ingredients. But what made it really exciting this year is the confirmation of the liquid water. So we'll get to that. But this is one serious problem on Mars. there's an atmosphere that lacks the protection of a strong magnetic field. Whereas Earth has this very strong magnetic field. Earth is a little bit bigger than Mars. If you think about it, the gravity of Mars is a little bit less than half Earth. Interestingly, the surface area on Earth, the dry part, if you take away the 2/3 oceans, equals the square miles on Mars. So if you want to think about how much effort it would take to explore Mars, it's exactly the same as the effort it would take to explore Earth, which has taken us millennia to do. So there's a lot of square miles on Mars. It's exactly the same as the square miles on Earth if you take away the oceans. But Mars does not have a magnetic field like that, and so this is what happens. This is the solar wind coming in, completely unprotected. 1 billion years, 2 billion years, 3 billion, just relentlessly stripping away all the volatiles. This is an escaping ion simulation, and they're going to match this to some data that were just taken this year from the Maiden spacecraft. It's a beautiful illustration. You can see the water from the ancient Mars that made it a very wet planet, much more Earth-like than it is today, and just being ablated constantly. There's actual data taken from the Maiden spacecraft. This is in orbit around Mars right now. This data came down just a few weeks ago, a few months ago actually, and you can see the match between the flux that was actually measured of particles escaping Mars right now and the model. And so this is, from NASA's point of view, strong evidence that Mars has been blasted for billions of years and just didn't have a chance to maintain the liquid water on the surface of the lakes and the oceans that we have on Earth. Big difference. So that's Mars yesterday. It was much more Earth-like, we think, from geological evidence. I'll show you some of that, but it just did not have the protection of our magnetic field. So add that to your list of beneficial things on Earth that we need to make sure we understand how they work, because there's no user's manual for Earth. We have to write it ourselves. And so we have to know what's important. And basically, it turns out every single detail about the Earth system is helpful to us. This is a schematic showing you the 4 terrestrial planets in our solar system. And I'm going to call Titan, which is a moon of Saturn, a planet in this context. So we have Mars here and Earth, and what is being plotted here is 3 different axes. And it's just sort of qualitative. You have pressure, like the surface pressure. Most of you are probably aware that on Mars, you would have to take out about 99.5% of the air in this room to get down to the Mars atmosphere. It's 6 millibars instead of 1,000. So it's almost a vacuum. So Arnold Schwarzenegger took his helmet off in one of these movies, and the skin explodes. Matt Damon had to go to all kinds of trouble in the Martian movie to not be exposed to the Martian atmosphere itself. So it's really, really low on the pressure scale. Titan, interestingly, this moon of Saturn, has a pressure of 1.5 atmospheres. 50% more pressure than in your lungs right now, than in this room. It's a little moon. It's not a whole lot bigger than our moon. Just phenomenal, interesting. Venus is the planet that's almost exactly the same time as Earth. It has very high pressure, 90 bars, 90 times the pressure in this room. And also hot, like 700 Kelvin. It's hot as a Pizza Hut oven on the surface of Venus. So very inhospitable. And then we have this gorgeous Earth here. So pressure on one size, you can see Venus and Earth are almost exactly the same. Mars is a little bit smaller, the smallest. And then rotation means the speed of the planet. Mars is almost exactly the same 24 hours as Earth. It's just a half an hour longer. It's almost the same. To work on Mars, though, because of that slight difference, you have to have a special watch. And so the Curiosity team and the other rover teams have all had special watches built that are on Mars time. A Mars day is called a what? Does anyone know? SOL, a SOL. And it's just a little bit longer, half an hour longer than a day on Earth. And so after a couple of weeks, it starts to lap. And so they are on a different schedule. It's a different planet. So high rotation, whereas Titan and Venus have very slow rotations. That affects the storms and the atmospheric dynamics that you see on this planet. This is one of my favorite graphs comparing these. You see Venus, Earth, Mars, and Titan. And what you got here is an exaggerated scale, but it's relatively the same. You have Maxwell-Montes, this enormous mountain system on Venus, our Mount Everest, and then Olympus Mons, which is the largest shield volcano in the entire solar system, absolutely huge and broad. And then not much in the way of mountains on Titan, but there are lakes. There's actually liquid lakes of methane on Titan. But what I see first, what do you see? Just drive by quickly and you look at this slide and you see color, right? You see dead, 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 and alive. You see inviting, gorgeous, blue, viscerally beautiful, and then you see acid or just dead, right? Well, I'm a planetary scientist. I spend all my time working on other planets. And when I come back in my head to this planet, it's just shocking how different, how beautiful this planet is, how inviting and how welcoming this planet is, nurturing. All the other planets are all dead. Every planet we could talk about, every comet, we haven't discovered life on any of the other ones. So that's why it's so exciting that we have finally liquid water. And I'm going to elaborate on the actual need for the water to be liquid in a couple of slides here. Mars, interestingly, gets so cold up at the upper atmosphere that its atmosphere itself, can you see CO2 cirrus? It's in small print at the top. The atmosphere itself forms clouds. That would be like nitrogen clouds in our atmosphere. Not water clouds, nitrogen, the air freezing into a cloud. It also freezes on Mars on the pole, on the winter pole. So much of the atmosphere freezes on the winter pole that the pressure during winter goes down 30%. That would be like the pressure in this room going from 1,000 to, if you go to Denver, you're a mile high, you have about 800 millibars pressure. You'd have to go even higher than that.